Okay, so if you guys remember, what we want to do is first we want to count the valence electrons. So if we look at hydrogen, how many valence electrons does hydrogen have? 1. Yeah, so there's 2 hydrogens, so it's going to be 2, but each hydrogen is the first box, so it's going to be 1 valence electron each for a total of 2. Okay. All right, next we got to go to oxygen. How many valence electrons does oxygen have? 6. Yeah, 1, 2, 3, 4, 5, 6. All right, and then we got 2 of them, so we're gonna have 12 in total. So we got a total of 14 valence electrons to work with. Okay, so that's the first thing you want to do. You want to count the valence electrons. All right, now we're going to organize the atoms so that we get our general structure. Now, if you guys remember, hydrogen always goes on the outside, right? And so if we take a look at the structure, we got 2 hydrogens, so let's put them on the outer ends. And then we got 2 oxygens, and so they can't go on the outside, so we'll put them kind of like this. Let me write that a little bit bigger. Okay, but we put the hydrogens on the outside, and then oxygens go in the middle. Okay, next we're gonna connect everybody together. So hydrogen connects to oxygen. This hydrogen connects to oxygen, and then let's connect the 2 oxygens together. Okay, that way everybody is connected. All right, so we drew 3 lines. So if we draw 3 lines, how many electrons do we use? 6, yeah, because each line is 2. So we use a total of 6, so we got 8. Okay. All right, so we got 8 electrons that we still need to use, and so we got to put dots, right, on these atoms. So we look at hydrogen. Hydrogen has 1 line next to it. So this hydrogen has 2 valence electrons, so this one is happy. Okay. This hydrogen right here also has 2 electrons, so he's happy. Okay, but if we look at this oxygen, how many electrons does this oxygen here have? Not 2. How many lines are next to this oxygen right here? Yeah, there's 2 lines, so it has 4 electrons. Okay, but if you guys remember, everybody wants to have 8. So what we got to do is we got to add electrons to this guy until it gets to 8. So if we have 4, we got to add 4 more. So 1, 2, 3, 4. And now this guy is happy. Okay, and so we used 4, so we have 4 left. And then you guys kind of get the drill. We put 4 more here, and then we're good. And now everybody is happy. So this right here is the structure for H2O2. Okay. Alrighty. Hopefully not too bad. Any questions on the steps? You guys good? You guys look so excited today.
Yeah.
To learn chemistry on a Friday morning. All right. So today we're going to be learning about something called double and triple bonds. So up until this point, we've only been drawing 1 line between the atoms, right? And so now that you see the name of the lecture, double and triple, but it's not too bad. It's the same thing. We're just going to be moving some electrons around. Okay. So the lines that we've been drawing so far, they're called single bonds, okay? So this is the super long definition. So if you guys just want to write the short definition of a single bond, you can just think of it like this. 1 line, and it equals 2 shared electrons, okay? So write this part down. A single bond is 1 line between 2 atoms, and it's when you share 2 electrons. All right, so that's a single bond. So pop quiz. If we have a double bond, how many lines do you think there are?
2.
Dude, amazing. You guys are incredible. Honors. So honorable. Okay, so if there's 2 lines, how many electrons do you think are being shared? Wow. 4. Genuinely impressed. Okay. All right, so basically everything we've done so far, single bonds, one line, two electrons, and then we're gonna have, but then you can also have two lines in between two atoms, and that's when there are four shared electrons. I know, it's amazing, huh? I do. I teach all the levels, unfortunately. Yeah, I hate chemistry. Just kidding. Okay, so let's take a look at O2. So O2 is oxygen gas, what we're breathing right now. So we said earlier that oxygen is 6 valence electrons, right? So that means we have a total of 12 valence electrons that we're going to work with in this structure. Okay, so we're going to be working on this one. Alrighty, so if we take a look at O2, it's made out of 2 oxygens, right? So we're gonna draw 2 oxygens, so O and O. Okay, so 2 oxygens. And what we have to do is first we need to connect them together, right? So we're gonna draw one line in between them. Okay, so if we draw one line, how many electrons did we use? 2. So now we have 10 left over. All right, now I'm sure you guys know we're probably going to use a double bond, but please entertain me because I'm going to show you guys why we need to use a double bond. Because a lot of times you won't know if it's a single bond or a double bond that we need to use. So if we take a look at this oxygen on the left, how many electrons does it have right now?
2.
Yeah, 2. Okay, and then same thing with this guy right here. This guy also has 2 valence electrons, right? So if we start with the one on the left, how many electrons does this oxygen still need? It has 2, and everybody wants 8. So how many do we need to add to this guy right here?
6.
Yeah, 6. Because if we add 6, right, that means this guy is happy now. It's at 8. He's happy. He has a complete shell. He's not unstable anymore. Okay, does that make sense? Okay, so we used 6. So how many electrons do we have to work with? 4. Okay, now if we go right here, how many electrons does this oxygen still need? Yeah, it needs 6. Okay, but the problem is we only have 4 left to work with, right? So we're going to add 1, 2, 3, 4. And so now this oxygen has 6, but it's still sad. But now we don't have any electrons to work with. I know. This is horrible news. Okay, so what we're going to do is, you guys see how this guy has a complete shell, right? What this oxygen is going to do is it's going to force this oxygen to share 2 electrons with him. So it's going to create this double bond. And so if we take a look at this oxygen, it still has 8 electrons. There's 1, 2, 3, 4. And then all the lines are 2. So 6, 8. And then now this guy also has 8. 1, 2, 3, 4, 6, 8. Yeah. Yeah, so it's going to be double and then triple, and that's it. Triple's the most you can do. Yeah, no quadruples.
6.
Hmm?
Triple, that's 6.
Genius. How did you even guess that? Gut instinct. Yeah. All right, does that make sense, guys? Okay, it's basically when you share 4 between 2 atoms. Okay. All right, so we'll go now to the next bond, which you guys already saw is a triple bond. And so if single is 1 line, double is 2 lines, what do you think triple is? 3. Wow. Yeah, 3 lines. So triple bond is 3 lines. Okay, and that's going to be equal to 6 shared electrons. Okay. So I think you guys get the general gist of it. So I'm going to give you guys about 3 minutes. I want you guys to draw the structure of N2. Okay, it's nitrogen gas. Okay, so I'll give you guys about 3 minutes. See if you can get the structure. Make sure you draw the lone pairs and count the valence as well. 3 minutes to do that, and then we'll go over it. And just a hint, you'll use a triple bond. So we're going to be working with N2, and so we got 2 nitrogen. So how many valence electrons does each nitrogen have? How many valence electrons does one of the nitrogens have? Yeah, 5. Count the boxes. Nitrogen is 5. There are 2 of them. So it's going to have 10 valence electrons. Okay. So far, so good?
Yeah.
Okay, so obviously we're going to have 2 nitrogens. And since we're doing a problem about triple bonds, we're going to have a triple bond, right? So let's put a triple bond in between, save ourselves some time. So if we put a triple bond right here, how many valence electrons did we use? 6. So we use 6 out of the 10. So we have 4 left. Now, if you take a look at this nitrogen right here, how many more electrons does it need still?
2.
Yeah, it needs 2. Okay, and then same thing with this guy as well. So we got 4 left, so we put 2 right here, 2 right here, and there you go. That's nitrogen gas. And if you look at the one on the left, there are 2 dots. So 2 electrons, and then 6 being shared, and then same thing on the right side. Yeah, what's up? That's totally fine too, yeah. As long as you got the same number of dots that I do. What's up? Yeah, that's a good question. So usually it's when you run out of electrons. Remember the example that we did earlier? We had the oxygen, single bond oxygen, and then we had 6 here, and then we only had 4 here. So here, this guy's not happy, but we don't have an electrons to add to it, right? So that's when you move these 2 right here, and then you move them in between with the line. That's how you would do it, yeah. So it's kind of like a guessing, not a guessing game, but like you're trying to figure out where to put them to balance everything out. Yeah. All right, you guys ready to try? Yeah. What do you mean? Yeah, because they're both O, but you just need to make sure they both have 8, regardless of how many dots you add and whatnot. Yeah. Yeah, you just use a combination of the lines and the dots to get everybody to 8. That's pretty much it. Alrighty, guys. So I'm gonna let you guys try one on your own. So this one right here, I'm going to just let you know, there are a combination of bonds. So when you have a molecule, sometimes you'll have only singles, maybe only doubles. Sometimes you'll have single and double. Sometimes you'll have single, double, and triple. Okay, so there's a bunch of combinations, but we'll start easy. This is a smaller molecule. Yeah, so try it out. Count the valence electrons. See if you can organize it. Use the rules that we've learned before. I'll give you guys about 3 minutes, and then we'll go over it together. Okay, so we have this compound right here, CH2O, and we're gonna start by counting the electrons. So I'm gonna do that for you, and you can just check your answer. But carbon is 4, hydrogen is 1 each, so we got 2, and then we got to add 6. We've been basically looking at oxygen the whole time. And so we got a total of 12, yeah. So you don't have to write like this process. If you can just mentally do it and just write it down, you're good to go. Yeah. Okay. All right. So we got 12 valence electrons. Let's start organizing the atoms. Now, one of the rules that you guys probably remember is that carbon goes in the middle, right? Carbon always wants to go in the middle, and hydrogen always goes on the outside. Okay, so what we're gonna do is we're gonna organize it like this. So we got carbon in the middle, and then we'll put hydrogen on the outside again. Okay, now depending on how you wanted to do it, you guys can see that we still need to put oxygen somewhere in this structure, right? Now, some of you guys might be tempted to put oxygen like right here or right here, but if you guys remember, carbon wants to be in the middle. It wants to be surrounded, so it wants to be surrounded by other elements. So oxygen also needs to surround it. So we're going to have to put it either on the top or on the bottom. Okay, so just keep that in mind. Carbon really likes to be in the middle. It thinks everything revolves around itself. Super selfish, right? Yeah. I also hate carbon. You're mostly made of carbon. What's up? Yeah, if you oriented it like, for example, are you asking like this? Yeah, that's totally fine. All you're doing is kind of tilting it, so that's cool. Exact same thing. Okay, so what we're going to do is now we're going to connect everybody. So everybody connects to carbon because carbon is the social butterfly and wants to know everybody's business. Okay, so we connect to carbon. Okay, so if we draw these 3 lines, how many electrons do we use? Thank you. How many electrons did we use, guys? 6. So we use 6. So we have 6 electrons left. All right, so if we take a look at hydrogen, okay, we're talking about both of them. Are the hydrogens happy?
Yeah.
Yes, because both hydrogens have 2, right? They have 1 line next to it. So this hydrogen has 2, this one has 2, so they are happy and good to go, okay? All right, if you look at this carbon, how many electrons does carbon still need? Yeah, it needs 2 more, right? Because it has 2, 4, 6. So this carbon needs 2. If you look at this oxygen, how many electrons does it need? Yeah, it needs 6. You guys see that? Because it only has 1 line next to it. All right, so the problem here is oxygen needs 6, carbon needs 2, but we only have 6 to work with. So what bond should we put in between them? Yeah, a double would help because we can use a double. We use 2, so we have 4 more. Now we got to change up our numbers. Carbon, how many electrons does carbon need now? 0. Yeah, this carbon is finally happy. Okay, and now oxygen needs 4, and that's exactly what we have left over. So there you go. That's going to be what this compound looks like. So a little bit tricky, but again, same thing as before. All we got to do is just keep putting electrons, dots and lines until everybody has 8. Okay, and if you want to answer the second part of the question, there are 2 singles and there is 1 double bond. Okay. All right, I'm gonna give you guys the rest of the class period to work on your assignment. Let me know if you guys have any questions or if you want to check your answers, okay?